Interest is a common
application when we are looking at exponential growth and decay. So when we're looking at interest, our main interest formula is going to look like A of t is equal to P times 1 plus R over N, and that is all raised to the nt. So what does this all mean? Well, there's a couple different things that we need to know. The first one is P. P references the principal, which is the starting amount. So for example, if you're going to create a bank account, you go into the bank, you're going to open an account, and they say, how much would you like to deposit? That's your principal. That's your starting amount. That's the amount that you started the account with. R is our interest rate. And you always want to represent it as a decimal. N is the number of compoundings per year, and I'll explain what that means in just a minute. And T is our time, which is expressed in years. And then the last one, we'll squeeze it on here, is A of t. And that is the amount at time t. So for example, if you want the amount after 5 years, it would look like A of 5. If you wanted the amount after 4 years, A of 4, and so on and so forth. So look at our formula, A of t. So the amount in the account at time t is equal to the principal, the original amount you invested, plus, times 1 plus the rate as a decimal over the number of compoundings raised to the number of compoundings per year times the number of years. We're going to put that all together as we look at our first couple examples here in number 3. We'll come back and look at the other formula here in just a minute. So let's look at number 3. If $3,000 is invested at 5% interest, find the value of the investment at the end of 5 years if the interest is compounded, and then we have some different compoundings. So we're going to look at parts A, B, and C. So annually. Annually means 1 time a year. So that means that our N is 1. If you have an annual compounding interest, then that means that your interest is calculated once a year. So that'll look like, well, let's see here. Let's go through and label what we have. We have $3,000. That's our initial investment. So that's our P. We have 5% interest, but we need it to be as a decimal. So that will look like 0.05. We have, what else do we have? 5 years. So that's going to be our time. And looks like that's all we have in the original. So for this first one in part A, we have our N is equal to 1. Let's start with our original equation. So our A of t, our amount at time t, is equal to the principal times 1 plus R over N raised to the nt. Now let's put in what we know. So we're still trying to find this amount at time t. So we're still going to have our A of t. Our principal is 3,000. Then the 1 is always the 1. So 1 plus our rate is 0.05 over N. Well, in this case, N is 1 raised to the 1 times our time, which in this case is 5. There we go. Now we need to put it into our calculator. So if we solve this down, we'll have our 3,000 right here. 0.05 divided by 1 is just 0.05. So this will look like 1.05. 1 times 5 is 5. So we can type it in just as you see it here. To do the raised to the 5, you're going to have to use your exponent key on your calculator, so be careful. Now, when you do this, you need to type it in how you see it. If you're using a graphing calculator, you can type it in just as it is. If you are using a scientific calculator where each time you push equals or something like that, it changes the screen, then you're going to need to do your 1.05 to the 5th first, and then multiply by 3,000. Be careful. The thing that you cannot do is multiply the 3,000 times the 1.05 and then raise the whole thing to the fifth. That will not work because it's not these two values raised to the fifth. It's just the 1.05 raised to the fifth. If you're not sure, do 1.05 raised to the fifth first and then multiply by 3,000. Make sure you're able to type this into your calculator and get it to have the right result. So we have 3,828.84 for our amount. So this is what it will look like if it's compounded annually, so meaning one time per year over 5 years. So it looks like you make about $828 in interest. So let's see what happens if it is compounded weekly. Well, weekly means that the number of compoundings would be 52 because there's 52 weeks in 1 year. So we'll start off the same way. We have our amount at time t is going to look like our principal times 1 plus r over n raised to the nt. Now we need our amount at time t is 5 equals our principal, so 3,000 times 1 plus our rate. The rate didn't change, 0.05, but this time the number of compoundings did change, and it changed to 52. And then we have 52, and we have 5 years. So we've got everything plugged in there. So if we type this all through, make sure you're able to type it into your calculator. Type it all in, do your 1 plus your 0.05 over 52 first, raise that to the 52 times 5, multiply that by 3,000, and you should get, when you multiply it out, 3,851.61. Notice it's just a little bit higher than what we found when we were looking at our amount after 5 years for compounding one time a year. The more times it compounds, that's the more interest times that it's being calculated. So let's try part C. Part C is asking us for daily. So daily interest means that it's going to be compounded every day. So that means that our interest is going to be based on n equals 365. So start with our same formula. Our amount at time t is equal to p times 1 plus r over n raised to the nt. Now this time our amount after 5 years is going to look like our 3,000 times 1 plus r this time is still 0.05, but n is changing to 365. And it'll be 365 times our time of 5. So let's make sure that you are typing this in correctly. Do your 0.05 divided by 365, add the 1, raise it to your power, multiply by 3,000. And when you do all that, you should get 3,852.01. So the numbers are very close with the compounding of the interest, but they're all slightly different, and that's because it's based on the number of times that interest is compounded. And what happens for an interest being compounded, it means that the interest calculation is being taken and then put back in with the principal. So then as you take a new interest calculation, you're calculating on the previous interest. The other type of interest calculation is called compounded continuously, or continuously compounding. And what happens here is it changes our formula just a little bit because the n, the number of compoundings, is going to infinity. We can't put infinity in the denominator and then into the exponent. So this is where we bring in our e. So this will look like the amount at time t equals pe raised to the rt, where the e is taking the place of the 1 plus r over n. So let's see what this looks like. If we're looking at our compounding continuously, we're still looking at our a of t. We have pe to the rt. So we still need our a of 5 is equal to our principal of 3,000. E, our rate is 0.05 still, and our time is 5. Notice there's no n in this one. And the reason there's no n is because it's the continuously compounding and the n is approaching infinity, and we can't put that in. So that gives us 3,852.08. In part E, it's asking us, if the interest is compounded quarterly, how long will it take the balance to double? So we have to figure this out one piece at a time. If you start with $3,000 originally, and it's going to double, that means that you are going to $6,000. So let's say that you're trying to save for a new car. You're looking at a down payment on a new car, and you have $3,000. You're going to invest it, and you're going to see how long it takes for it to double so that you have $6,000 for your down payment. So that means that your A of T, the amount that you want, is going to be $6,000. So we're trying to find out how long. Well, how long means that we want to find T. So you still have your same original principal amount. You still have your $3,000 as the principal, but you want your amount at the time to double. So $3,000 is our principal. The amount that we want, the A of T, is our $6,000. It says that it's compounded quarterly. Quarterly means 4 times per year. So once each quarter, 4 times per year. So that'll look like 1 plus, our rate hasn't changed. We still have that 0.05. Over, in this case, our number of compoundings is 4, and we have our 4 and then our time. We're trying to find the time, so we have T. Right? Let's divide both sides by 3,000. If I divide both sides by 3,000, I'll get 2 is equal to 1 plus 0.05 over 4 raised to the 4t. I need to get the t out of the exponent. And the way we get a t out of the exponent, or any variable out of an exponent, is with the natural log. So if I take the natural log of both sides, that will leave me with the natural log of 2 is equaling 4t times the natural log of 1 plus 0.05 over 4. So now we need to figure this all out. Well, let's do a little bit of an intermediate step so we can make sure we're getting it typed in right. So we have the natural log of 2 is equaling 4t. And if you type in the natural log of 1 plus, and then we need the 0.05 over 4, it's going to look like the natural log of 1.0125. So simplifying this part right here in the parenthesis, the 1 plus 0.05 over 4 to 1.0125. So now we need the natural log of 2 divided by the natural log of 1.0125, and that'll be equal to 4t. Because right here, we're dividing both sides by our natural log of 1.0125. So we're left with just the 4t. So when we divide this down, we also need to notice we have a 4 here. So let's go ahead and divide by our 4, which will put our 4 right here. And then we'll be left with t is equaling 13.95 years. Be careful with typing it in. It gets very, very tricky. If you solve it down in pieces, sometimes that's a little bit easier to try to type it in. Let's see what happens for part F. If the interest is compounded continuously, how long will it take for the balance to double? Well, here we go. We need it doubled, so we need our amount to be 6,000. We started with an initial principal of 3,000. We have our continuously compounding formula, which was our A of t equals PE to the RT. So here we have A of t is 6,000, P is 3,000. We need our E, and we need to raise that to the R. R is our rate, 0.05, and our time. So divide both sides by 3,000. Divide both sides by 3,000, you'll get 2 is equal E to the 0.05 t. Our t is still in our exponent, so we still need to use our natural log to bring our variable down. So that will leave us with the natural log of 2 is equal to 0.05 t. Now the E and the natural log. If we have natural log of e, these cancel each other out. So that's gone, it's finished, we don't need to consider that anymore. We have the natural log and the e, they cancel each other out to 1, so we have 0.05t. So now we can use our natural log of 2, divide by our 0.05, and that will leave us with t. So typing all this into your calculator, you should get 13.86 years. So it saves a little bit of time, not a lot, but it does save a little bit. So this is our compounded interest.